with the concept of breeding blueprint present in the previous lesson video. Now I just want to walk through with you the one real project drawings that you can apply and relate what we learned in the previous video. So just mention briefly that we state in the previous video. For the set of plan, they have a general node G, civil C, architectural A, structural S, mechanical M, electrical E, piping and instrumentation diagram P and ID. And it also in drawing, normally they have a title block with revision, abbreviation. If you need in drawing something that have abbreviation in that drawing, then you go to the general drawings, normally very top first few drawings to see the abbreviations, and then legends also the first few drawings in the set of plan for the project. So let's go to the drawing and see and look for all of this that we learned. The one that we refer is the reference for today's lesson, worksheet 6 reference, and the project, the real project that I'm going to use is the wastewater treatment plant project located in Madison, Wisconsin state. And this is the plan view of, and again, it's orthographic of the project. And as you can see, there are many items in here, and then they also number different item. 50 Chester number, and the item that we looking at is this area 75, 78. So what is 75, 78 here? 75 is the thickening building WAS wastewater pre-treatment tanks. So that is the one we do for this video, and the worksheet for today to do the quantity takeoff. And you can see different way that they show with different line, and go to the talking about the abbreviation. And you can see G, it stands for node. You look down here in the bottom right. So we have the G stand for the general node. So everything here that is G for the node. C stand for civil, if you recall that. SM is stand for S stand for structural, M stand for mechanical. So yes, basically yes, for this project, this item 78, which is for the general, it is the WAS pretreatment tanks that here, and that 78 that they refer to. And SM is mean that they combine for this drawing both structural and mechanical. So it piping here mechanical and then structural in there. So that drawing combine both. Typically they separate two trays, structural and mechanical, but this one they have one in one drawings, and then of course they have other drawings as well. So that is that what you have in the drawing. And as you can see, they have a title, they have a for title block, they have project, what is the project here, the plan here about, in this case the site work and general, and then the company that design, and you see the revision date, all of that, the owner, and who designed by, scale. So that is the typical, we call it in the PowerPoint here, the title block, revision, abbreviation, things like that. And then we go to try to read some information in this one. By the next one is from this drawing, and on Canvas, if you can put out in the PDF and write this by your own and pause this video, which drawings that have the symbol shown here, that you have here, the symbol that's shown, that B SM3, and then what are the differences between these two symbols? B 78 stand for the item, WAS tank, SM3, and then SM4. So how can I read where I can find that and what does that symbol stand for? So that is what I want to show you for this drawing here, so that you can be able to. So SM is mean structural and mechanical. So you have to look at on the drawing on the bottom left, bottom right, and you see this is C. So it's not what we are looking for. Going down further, and you see SM. So start with SM1 and then 2, 3, 4. So SM3, what is SM3? As you can see here in this, they show that it is B78 for the item 78, and then that is WAS tank, and then SM structural mechanical 3. But in this drawing, it shows 78 SM1. So what does that mean? To look it for this detail, this cross section, and the arrow here is stand for that you cut cross section, and you see the drawing, they cut from here to there to the tank, and they look from right to left. So look from right to left, because if you look one object from right to left and left to right, it may not be the same. So you need to show the arrow. So here they cut and they look from right to left in through this cut. So B here and B there. And where to look at that cross section, you need to go to the drawing number 78 SM3. 78 SM3. So go down, you see SM1, and you can see there. And then we SM1, then we have SM2, and you see SM3 that we stop here. And this actually the bottom left here show that cross section. So cross section, and that look from right to left. So that cross section you through the tank, and then you can be able to determine what is the bottom of the tank, and you can see there the bottom, and this is the goal, the tango for both sides, and then this is the roof of the tank, slope of the tank, the beam, all of that you can read, and then apply the concept of reading. We can be able to know what is the thickness of the tank, of the bottom tank. For example, here you can see that is okay. The bottom is the thickness of the bottom of the tank, 1 foot 6 inches, and then you also be able to read the elevation, the finish to the top of the bottom of the tank is elevation 19 feet. The top of the roof is 3642 feet on this side, and of course the other side it had 37 feet. So that you can be able to read. And then if we're talking about the rebar, the reinforcement for the tank, is here concrete, and you can see the reinforcement here. You can see number 6, something we did in problem 3 of the lesson 5, previous lesson. 6 inches on center, so that here EW, if you don't know what is EW, it's not east-west, but it's each way in this case. So look for the general drawing abbreviation, you can be able to find that out. T and B stand for top and bottom. It also have that in the general abbreviation. So it means that for the reinforcement for the bottom slab of the tank, it need to be both top and bottom, and each way it means go this way and go the other way, and use the concept that you learn to determine the number of rebar, and then go to find out number 6, what is the weight per linear foot. You can be able to determine the quantity of the rebar. And then of course with the thickness of the bottom of the tank, for example, 1 foot 6 inches, and then you find out, okay, for the tank it should be just like the slab. I need to find out, to find the volume, I need to find out the thickness. I already find out in that drawing 1 foot 6 inches, and then I need to find out the width and the length, and you can time your 3 dimension, you can find out the volume of the tank. And like I say, because this is orthographic method, you cannot read one object in one drawing, one section. You have to read with multiple view. In this case, that is the section view. Then we can go to the plan view of this. This is plan view, and that is in 78 SM1. I also suggest you to pull that out, that drawing, to see. And actually we can be able to, with that plan view, I can see the side for the tank and see there, right? So you can read one side of the tank can be read on this side. So that is the, for example here, the tank from the bottom, so from there to here, so it will be 57 feet and 8 inches. You can see there. Okay, so one side, and the other side of the tank you can be able to read down here from the edge there to the other edge, so it will be that 116 feet and 4 inches. So I be able to find out that in the this drawing, the length, the width, the thickness in the section B in the other drawings, 78 SM1 and the other drawing 78 SM13, I can be able to find out the volume of the concrete for the bottom of the tank. The process do the same for all other. In that concept, we can apply to the worksheet problem today, only one with this for this method. So with that one, I go back to here so that you see the difference. And so bottom line, go back here. So that show the section B and view from right to left, and you can see that detail of that section at the drawing number 78 SM3. The difference between these two, also the cross section, but you see that in SM3 and SM4. So even they put B, but it might not be that the view, the section are actually the same section. And I'm going to show you that here. With that here, we already say the section B, and that we look at in the drawing 78 SM3. So I can go back there, I see that, okay? But then SM4, you see the detail B, 78 SM4, and that cross section, as you can see, not yet. So B, don't say B is the same, right? That one, it means where I can look at the cross section of this. SM4 is mean on that same cross section, and the cut B in here. So they cut there in the same drawing SM4, and they show the detail on the same drawing. And as you can see now, this detail B, 78 SM1, 78 SM2, that from in the drawings SM3, but that cut, if you want to see that cut, where that cut come from, go to the these two drawings, go to these two drawings, go up to these two drawings. Yep, so that is this SM2, I see that drawing, and the detail to the SM3. Similarly, I see that drawing and the detail go to the drawing number 78 SM3, and which is the detail shown here. So with that in mind, be able to read, coordinate different drawings to see what is that about. It's very important and that critical for the success of project one that we are going to introduce today lesson. So last one about the specification. For example, this one I extract from the Three Oak wastewater treatment plant project in Three Oak Parkway, just up near our campus. Just that one here. So what is that about? So I show you this is the specification for the Three Oaks wastewater treatment plant, and that plant oxidation ditch improvement in Lee County, Florida. So they have table of content, and here, as you can see, we talk about last lesson about the master format, division 1, division 0, division 2, etc. Division 3 concrete, masonry, mantle, etc. So all of division they show in here, so that follow the master format as I mentioned to you. And then in each of the division, they will specify what is supposed to do. Just for example, in here, that is what is the section 11 378 should be. In this case, supply and installation oxidation ditch. Number 4, equipment, how many horsepower for the surface aerators, etc. So they specify, and who can provide that equipment for this wastewater treatment plant, they will specify that in here. Something like this cannot be so in detail in drawing, but you need to refer that in specification. So it will be a written long drawing. Just as you can see for this real project, it have, if you see the page here, just only one volume, it already almost 1500 pages. So with that, in the next, I will show you, and of course I encourage you to practice to do the quantity takeoff with the one problem we did in today's lesson.